teach petrography courses in English with the lecture notes of the Middle East Technical University, Department of Geological Engineering. Remember, the Mining Association is a worldwide channel. That's why we have to be broadcasters in English. We hope to have publications in other world languages in the future. Remember, learning should no longer be individual, but global. Hand in hand with the whole world, sometimes we may have amateurish mistakes due to our technical inadequacy. I remind you that we are preparing these publications out of impossibility. Same in all directions. Gases, liquids, amorphous and cubic minerals, isometric system, anisotropic. Physical properties. Variable with crystallographic directions. Minerals in tetragonal, orthorhombic, hexagonal, monoclinic and triclinic systems. Best displayed in optical properties. Polymorphism. Physical properties. Related to atomic street. Bonding forces and chem. Composition. Minerals having same chemical composition with different crystal structure as a function of changes in P and T or both. Crystallization in different symmetry systems, different physical properties. Polymorphism. Minerals polymorphous. Dimorphic. Trimorphic. Polymorphic number of species in the group. Dimorphic comp. Sg. System hardness. Diamond Dc 3.51 cubic 10. Graphite Hec 2.23 hex. 1 to 2. Calcitecaco 32.71 rom.3. Aragonite Carco 32.95 ortho.3. 5 to 4. Trimorphic. Andalucitial 2CO 53.13 minus 3.16 orth.6. 5 to 7.5. Cyanatial 2CO 53.53 minus 3.65 tri.5. 5 to 7.0. Silicimanital 2CO 53.23 minus 3.27 orth.6. 5 to 7.5. Polymorphicum. Sg. System hardness. Low quartzio 22.65 hex.7. High quartzio 22.53 hex 7. High tridymite CO 22.26 mono, orth.7. High cristobalite CO 22.32 cubic, teta, 6.5. Coisite CO 23.01 mono 7.5. Stashovitizio 24.35 teta 7. Characters depending upon cohesion and elasticity. Characters depending upon specific gravity. Characters depending upon light if. Characters depending upon magnetism V. Characters depending upon crystal and aggregates HABITSV. Characters depending upon senses physical PROPERTIESPHYSICAL properties. Cleavage, parting, fracture, hardness and tenacity. Characters depending upon cohesion and elasticity. Cohesion. Force of attraction existing by the way molecules. Resistance to any external influence, e.g. breaking or scratching, bonding force. Elasticity. Force tending to restore molecules of a body into their original position. Cleavage, a tendency of a crystalline mineral to break in certain directions, yielding more or less smooth planar surfaces. Planes of lowest bond energy. Minimum. Value of cohesion. Amorphous bodino cleavage. Cleavage planes. Usually to the crystallographic planes. Cleavage. Consistent with symmetry. Cubicoctahedral. Dodecahedral, rhombohedral, prismatic and pinacoidal, basal, pinacoidal. Text box, classified according to their distinction and smoothness. 1. Good, distinct, perfect. 2. Fair, indistinct, imperfect. 3. Classified according to their distinction and smoothness. 1. Good, distinct, perfect. 2. Fair, indistinct, imperfect. 3. Poor, in traces, difficult. Related to the atomic structure in several directions. Depending on the force of cohesion. Some more developed than the others. Compared with other atomic planes, distance by the way cleavage planes must be large right pointing arrow electrical forces small right pointing arrow cohesion less. Cleavage planes. Pearly luster due to partial separation of crystal into parallel plates and reflection of light from these plates parting subjected to external force. Breaks along planes of structural weakness. Due to pressure, twinning, exsolution. Resembles cleavage but not continuous on crystals. Basal parting, rhombohedral parting. Cleavage fragments of fluorite. Cleavage fragments of muscovite. Kinds of fractures: conchoidal, smooth fracture, quay, glass, fibrous and splintery, sharp-pointed fibers, asbestos, serpentine, uneven or irregular, rough and irregular surface. 7. More or less smooth surfaces, may resemble cleavage. Hackley, jagged fractures with very sharp edges, matte fracture. Strength of the bonds approximately same in all directions. Some crystal structures and amorphous solids. Irregular surfaces. Text box, kinds of fractures: conchoidal, smooth fracture, quay, glass, fibrous and splintery, sharp-pointed fibers, ASB. Hardness. Resistance to scratchingedness, H. Scratchability, related to attraction force by the way atoms. Degree of H determined by observing comparatively relative ease or difficulty with which one mineral. Scratched by another, or by a fingernail, file or Nifimo's scale of hardness. Relative scale. Series of 10 common minerals. B. Austrian mineralogist F. Mohs, 1824. Number 7 quartz. Number 8 topaz. Number 9 corundum. Number 10 diamond. 1. Talc. 2. Gypsum, fingernail greater than 23. Calcite. 4. Fluorite. 5. Apatite, knife greater than 5. Window glass. 5 and a 26th. Orthoclassifial. 6 and a 27th. Quartz. 8. Topaz. 9. Corundum. 10. Diamond. Number 1 talc. Number 2 gypsum. Number 3 calcite. Number 4 fluorite. Number 5 apatite. Number 6 orthoclase. Oxides and silicates. Right pointing arrow, hard right pointing arrow, more than 6. Few exceptions, e.g. talc. Relation by the way H and chemical composition. Very characteristic and useful in identification of minerals in hand specimens. Native minerals. O. Ag. CU. Right pointing arrow, soft right pointing arrow, max. 3. Sulfides. Right pointing arrow, mostly soft right pointing arrow, max. 4. Exceptions. Right pointing arrow minerals with Fe. Company. Ni carbonates, sulfates and phosphates right pointing arrow soft right pointing arrow max. 5. Most hydrated minerals right pointing arrow soft right pointing arrow max. 5. Tenacity. Resistance to breaking, crushing, bending, cutting, drawing or tearing. Cohesion brittle. Breaks and powders easily, sulfides, carbonates, silicates and oxides. Malleable. Hammered out without breaking into thin sheets. Plastic, native metal. S. Sectile. Cut with a knife into thin shavings, native metals, ductile. Drawn into wire, native metals. Flexible. Bends but retains its bent form. Not resume its original shape right pointing arrow permanent deformation, ASB, clay minerals, CHL, TAL. Elastic. After bending springs back and resumes its original position, mousse. 2. Characters depending upon specific gravity. SG, relative density. Unitless. Number. Ratio BTW, weight of substance and weight of equal volume of water at 4 max. Density. Weight of a substance per volume equals gram per cc. Variable from one locality to another, max. At poles, min. At equator, SG. Measure with a simple balance. Weighing specimen plus in air war. In water, WW, SG equals wa WW. Volume of substance. Specimen. Clean. Free. Air bubbles. Cavities. Mineral. Composition. Atomic. Aragonite Carco 340.082.94 Strontianite SCO 387.623.78 Witherite Barco 3137.344.31 Sarusatepco 3207.196.58 Mineralsworth Metallic Lustus G greater than 5. Pit equals 5, Gal equals 7.5, Mat equals 5.18. In isostructural compounds, those with heavy element. Higher Sg. Relation between Sg and other physical and chemical properties. Relation between Sg and other physical and chemical properties. Mineralsworth non-metallic luster. Scave. 2.6-3.0. Quay equals 2.65, Fels equals 2, 60 to 2.75. Hydrated and soft minerals. Sg less than 2.6. Hartmannsworth heavy elements senior, bar, Fe, W, Cu, Ag, Pb, Hg. Sg greater than 3.5. In solid solution series. Continuous change in Sg with change in chem, comp. Phos equals 3.3, Fe equals 4.4. In polymorphous compounds. Closest atomic packing. Higher Sg graph equals 2.23, Dia equals 3.5. 3. Characters depending upon light diaphanate, amount of light transmitted or absorbed by a solid. Used strictly for hand specimens. Most minerals. Opaque in specimens. Transparent in thin sections. Transparent. Object behind it. Seen clearly. Quay, flu. Size of specimen. Text box, 3. Characters depending upon light. Translucent. Light transmitted but object not seen. Onyx marble. Opaque. Light wholly absorbed, hem. Color wavelength of the visible light region. Reflected or transmitted from the mineral. Human AA. Sensitive BTW 4200-7500A. Observed in white light. Mineral. Monochromatic light. Change in color of mineral. Interaction of electromagnetic radiation with a material. Energies correspond exactly to the energy difference between electronic levels of atom. So electrons being excited from one level to another. Not absorbed. Interfere on each other. Color of mineral. In ionically bonded crystals. Next energy level of unoccupied orbital greater than energy of visible light. No absorption. White or colorless. Impurities. Cause of color. Feldspar, green, pink, white, gray, etc. Colorless gypsum. Malachite. Turquoise. Fluorite. Amethyst. Street color of mineral powder. Color. Variable. Bud streak. Usually constant. By rubbing a mineral on a hard H=7 white, unglazed porcelain. E.g. hem. Color. Dark steel gray or iron black. Streak. Reddish brown to cherry red. Luster. General appearance of a mineral surface in reflected light. Degree of reflected light. Directly related to. Optical properties, mainly refractive index, Re. Other surface conditions. Metallic luster. Non-metallic luster. Most of all minerals with high content of metals. Imperfect metallic, submetallic. Other luster types. Poor reflection, scattered light from minimum surface. Text box, non-metallic luster. Related to Re. Adamantine exceptionally brilliant luster. High Re. E.g. deer, zir, corvitrius. Broken glass. E.g. silicates, quay, carbonates, cal. Strictly opaques. Light is completely reflected from the surface. E. Related to special mechanical and chemical properties of mineral surfaces. Resinous. Greasy, yellow resins, G. Sphalerite, S. Oily glass due to light scattered by a microscopically rough surface. E.g. nep, massive quapilipal like due to reflection from successive layers, e.g. surfaces parallel to cleavage. E.g. talc, mica mineral silk like due to reflection from fibrous structure of minerals. Gyp, ASB, malachite earth little or no reflection from surface due to the porous and fine-grained nature of mineral. E.g. lim. Vitreous luster. Greasy luster. Metallic luster. Adamantine luster. Resinous luster. Silky luster. Pearly luster. Earthy luster. IV. Characters depending upon magnetism. Basic cause of magnetism. Orbital and spin motions of electrons. W. The electric field of an atom. Charged particle in motion creates magnetic moment. Spin and orbital motion of electrons produce magnetism. So, diamagnetism. Opposing spins, up and down, of two electrons in the same orbital of an atom. Zero net magnetic moment. No attraction for a magnet, in fact they are slightly repelled by a magnetic field, G. Cal, alb, quay, ARPA etc. Ferromagnetism. Metallic. By the way grains. Randomly arranged. When placed in a magnetic field all the domains of all grains will be aligned parallel to the external magnetic field. Magnetic moments. To each other. WTH grains. Ferromagnetismonic spin moments. Anti-parallel magnetic moment of some of the neighboring atoms. So line themselves in opposite direction. Cancel each other. Become permanent magnet seg. Mat Fe 304 Ulvospinal Fe 2T04. Permanent magnetism of ferromagnetic minerals. Study of ancient geomagnetic fields of Earth paleomagnetism. Ferromagnetic mineral, e.g. mat. Crystallizes from magma. Assumes magnetic field of Earth at crystallization place. Position of the continents during geological time. Text box, V characters depending upon senses. V. Characters depending upon census tast. Most minerals no taste. Asterigent. Tastchev vitriol HCl. Saline. Tastchev salt. Halotenoclalkaline. Tastchev soda NaCO 3 cooling. Tastchev saltpeter or niter KNO3. Bitter. Tastchev Epsom salt ZO4, 7H2O. Sticky. Tastchev clay minerals. Odor. Most minerals no odor. Garlic. Minerals with ash or ceradish. When heated, minerals with sebituminous. Asphaltite, petroleum product sulfurous when heated, minerals with S. Fetid. Smell of rotten eggs. Minerals with S, when heated H2S evolves. Argillaceous. Moistened clay minerals. Feel. Smooth. Sepiolite. Greasy. Talc. Harsh. Rough surface and harsh feel. Cold corundum Al 203. Sticky feel to the tongue. Clay minerals heavy. High Sg. Gal. Crystal habits and AGGREGATESCRYSTAL habits and aggregates. Specialtums. For habit or general form or appearance of single crystals, crystals grow together in aggregates. Isolated or distinct crystals. Groups of distinct crystals parallel or radiating groups of individual crystals aggregate composed of scales or lamellae aggregate composed of aquant grains miscellaneous. Isolated or distinct crystals isolated or distinct crystals. Aciculars-slender, needle-like. Rut. Text box, isolated or distinct crystals. Capillary and filiform hair-like or thread-like. Sid. Bladed. Elongated, flattened knife-like. Kya. Some symmetry examples. Isometric. Diamond. Tetragonal. WULFENITE. Hexagonal. Beryl. Trigonal. Quartz. Variety, amethyst. Orthorhombic. Tanzanite. MONOCLINIC. Gypsum. TRICLINIC. MONTEBRASITE. Amorphous. Amber. Text box, groups of distinct crystals. Groups of distinct crystals. Groups of distinct crystals dendritic and arborescent. Slender divergent branches, plant licheniative tube, Ag, O. Reticulated lattice-like slender crystals. Divergent or radiated. Drussy. Surface covered with a layer of small crystals. Parallel or radiating groups of individual crystals. Parallel or radiating groups of individual crystals. Column as tout, column-like. Quay. Text box, parallel or radiating groups of individual crystals. Bladed. Aggregate of flattened blades. Stibnite. Fibrous. Aggregate of slender fibers, radiating or parallel. Rut. Coloform stellated. Radiating individuals forming star-like, circular groups. Globular. Radiating individuals forming small spherical or hemispherical gruption. Botryoidal, same as globular, resembling bunch of grapes, hem. Reniform. Same as globular, but in kidney-shaped masses. Mammillary. Same as globular, but in mammary-shaped masses. Same as globular, right pointing arrow, mammillary, agate. Aggregate, composed of scales or lamellae. Aggregate, composed of scales or lamellae. Foliated. Thin plates and leaves. Micaceous. Same as foliated but splits into exceedingly thin sheets. Text box, aggregate composed of scales or lamellae. Micas. Lamellar or tabular. Flat, plate-like. Plumose. Fine scales, with divergent or feather-like structure. Aggregate, aggregate composed of a quantiquant grains granular. Equal-sized anhedral grains, fine, medium or coarse. Massive. Miscellaneous stalactitic. Successive layer in cylinder or cone shapes. Concentric. Spherical layers around a common center. Basaltic. Rounded masses about pea-sized. Oolitic. Same as basaltic, about fish roe-sized. Banded. Narrow band of different texture and color, chromite. Amygdaloidal. Almond-shaped, zeolite minerals, cal-filling vesicles in basalt. Geode. A rock cavity wholly or partly filled with same or different minerals. Banded ore with crystals projecting from walls, agate. Large geode lined with amethyst crystals. Concretion deposition around a nucleus, spherical or irregular shapes. Nodular. As nodules.